Hello everyone. A bit over a year ago, I decided to make a universal serial adapter. And then I did this to it. Sometimes you need a UART, sometimes you need an old-fashioned RS-232, and sometimes you need USB-C. So I made a practical little dongle that's all of the above, all at once, or separately, which is why I decided to snap apart at all the right places. Today I'm introducing a new version of it, since enough of you thought it was a cool enough gadget to get and use for a bunch of different reasons. So I decided to give it an upgrade. Once again, sponsored by JLCPCB. JLCPCB offers super easy, fast, reliable, and affordable PCBs and assembly. Getting a fresh design delivered, fully assembled after just a week really feels like a prototyping superpower. Getting experience with PCB design means you have to make a lot of mistakes, make them often, and fix them fast. JLCPCB makes that super painless, since it's super easy to iterate faster and getting to that final product in record time. And you're not just stuck with 2-layer PCBs and restrictive design rules either. With JLCPCB, you can grab a $30 coupon for your first 6-layer PCB order and get a PCB for just $2. If you're a new customer, you even get $123 of new customer coupons. If you're serious about speeding up your product development, I can genuinely recommend JLCPCB to get your project out the door faster. For the new revision, I decided to skip having the D-sub-9 and pin headers pre-mounted, so if you buy one from my shop from now on, I'll still include the headers, jumpers, and male D-sub-9 connector, but you have the choice if you want to mount a female connector instead, and how many headers you want mounted. Since you have to do a little bit of soldering, like for most of the things I sell, I've lowered the price a bit to compensate. And of course, if you think it's a cool project, you don't even have to buy it from me either, as the whole project is completely open source and all the files are ready to send off to a manufacturer like JLC or whoever you like. But still, thank you so much to everyone who bought the first revision. I appreciate the support so much. I haven't changed much for the new revision, but I thought it's improved enough that I shouldn't keep the improvements to myself. The design is still pretty much the same, but thanks to Caitlin from Australia for cleaning up the schematic. That's the amazing thing about open source projects, cool things emerge. It still has jumpers to select if RX, TX and control signals should be crossed over or straight, so you don't need an adapter if you want to change it. And pretty much every single line is broken out to either a header, solder jumper, or test pad, so there's a million different ways to experiment with it. And you might notice I'm using a horrifically yellow breadboard here for soldering in the jumpers. It's a punishment for not only being the yellowest, but also being the worst breadboard I ever bought. Some breadboards are better than others. This one is literally only good enough for spacing out 0.1 inch holes. I'm soldering up a set of 2 boards here so we can verify everything is the same as with the first version. I'm still using the same CH340G serial to USB chip because of the great performance over 1 megabit we saw last time, and the same SP3243 RS-232 transceiver because it works at both 3.3 and 5 volts. This isn't supposed to be a long video, so let's jump to the test. I've hooked up both adapters to the same computer and set the jumpers on one of the adapters in the vertical position for crossed over and the other in the horizontal position for straight. If you're wondering, then a computer would usually have the straight-through configuration and, for instance, a modem on the other end would internally have the lines crossed over, if that makes sense. I considered making the RS-232 transceiver active by default, but I decided keeping it inactive until an active line is detected is still the safest approach. But in this case, when we're connecting 2 powered down transceivers to each other, I power up one of them by temporarily shorting carrier detect, the DC-D pin, to 5 volts, which is enough to wake it up. As you can see, we get data through both ways. One minor thing I did with this new design is that I made the use of the 3V pin on the CH340 optional as opposed to completely unused for the last design. The reason is that technically the 3.3V line on the UART is supposed to be connected to the 3.3V line if it's running at that voltage. Since it's running at 5V by default, you have to cut a trace in a solder jumper before you consider switching to 3.3V level UART. The biggest change I made is moving around how the 3.3V regulator on board works. On the previous design, it would get separated from its enable signal when snapping off the USB-C section, and there was no pin to tap it on the USB side anyway. So with this new design, one end of the USB pin header has pins to tap 5V, and the other has 3.3V coming out of the regulator at up to 300 mA. It's pretty handy if you need USB lines and regulated 3.3V right here and right now. To make sure things haven't degraded with the upgrade, let's give my unscientific serial speed test a go. All the way up to 2 megabaud we make it through without errors, but of course that'll only work under near perfect conditions. Pretty cool for a technology that's been around for 66 years. You can buy the new version on my web shop or download all the files you need on my GitHub. Links are in the description. Either way, thanks for watching.